Hey guys, so this week we're going to spend a little bit more time on a unit circle, and last week we just looked for sine and cosine of an angle on the unit circle. So this week we're going to look at tangent, cosecant, secant, and cotangent. So all 6 trig functions, and we're going to do a little refresher based on what we looked at last week, right? So last week we said if we have an angle with the terminal side, with the initial side on the positive x-axis, and then we have a terminal side that kind of rotates, right? It rotates counterclockwise, and then depending on where it stops, I should have made that a little smaller. Depending on where it stops, let's say it stops right here. My terminal side stops right here, and here is the angle that is formed. This point that is on the terminal side has coordinates x, y, which corresponds with the vertical distance. That is your y value, right? And then the horizontal distance, which is your x value. And we had said that if I was looking for the sine of this angle, and this is my radius, which in this case in a unit circle the radius is 1. So if I was looking for the sine of my angle, sine is opposite over hypotenuse, right? So that would be y, or y over 1, opposite and hypotenuse. If I was looking for the cosine, it would be adjacent over hypotenuse, so that would be x. So we know that the xy coordinate of this point, y represents the sine of that angle, and x represents the cosine of that angle. And now, if we look at tangent, well, the tangent of this angle is opposite over adjacent, right? Based on what we know about right triangle trig. So that's going to be y over x. And then cosecant is just the reciprocal of sine. So if sine is y, cosecant is just 1 over y. Secant is the reciprocal of cosine, so that would be 1 over x. And cotangent is the reciprocal of tangent, so that would be x over y. So basically, once you have your point that is on the terminal side of whatever angle you have, once you find the coordinates of that point, then you can figure out all 6 trig ratios based on the angle. So let's use 3 pi over 4 as an example. So I'm going to have my terminal side of my angle, and I'm going to have it rotate. So remember, pi is 180 degrees, right? Pi is a straight angle, and a fourth of pi will be 45 degrees, and I want 3/4 of pi. So I'm just going to rotate it counterclockwise. 1/4, 2/4, 3/4 of pi will land me right here. So 3/4 pi is the angle that is formed. And if I can find the point, the coordinates of this point that is on the terminal side of this angle, x, y, then I would have sine and cosine. And this is where you use your unit circle, your reference from last week, or the one that I provided on the weekly guide. So 3 pi over 4, here it is. Here's my unit circle. I can see that 3 pi over 4 is over here. And here's my coordinates, right? My x coordinate, my vertical distance, my y coordinate, is radical 2 over 2 because it's a 45, 45, 90 triangle. So based on what we know about special right triangles, if the hypotenuse is 1, the 2 legs are also radical 2 over 2 and radical 2 over 2. So that's the x and y coordinate. And because we're on quadrant 2, the x part is negative because x is negative on this quadrant. All right, but all you really need to know is find the angle and then find the coordinates. Negative radical 2 over 2 and positive radical 2 over 2. So let's go back to that. So x is negative radical 2 over 2 and y is radical 2 over 2. Well, we said sine is y, so that's going to be radical 2 over 2. X is cosine, so that's negative radical 2 over 2. So your coordinate, your xy coordinate, basically gives you sine and cosine. Cosine is x, sine is y. And then you're just going to use this to figure out the rest. So let's do tangent. Tangent is y over x, so I have to divide. Tangent is going to be y, I'm going to do it down here, radical 2 over 2 divided by x, negative radical 2 over 2. Right? Since they're the same thing, when I divide anything by itself, it's just going to give me 1 except negative, so negative 1. Okay, and then for cosecant is the reciprocal, so I'm going to have, instead of radical 2 over 2, this is going to be 2 over radical 2. This problem is also number 7 on the worksheet that you have to do as your first assignment, so this will be a good explanation for that. So 2 over radical 2, and then this is basically it, the reciprocal of sine, except remember we had said that we don't like having radicals in the denominator, so we got to rationalize it by multiplying by a special 1. Radical 2 over radical 2. Okay, and simplify. So that's 2 over radical 2 divided 2 times radical 2 divided by radical 2 times radical 2 is radical 4, which just simplifies to 2. And then we reduce it, and the answer is just radical 2. That's for cosecant. And secant is really the same thing, right? Just because cosine is the same as sine negative in this particular case. And so I'm not going to do all of that again. I know that when I flip it over, it's going to be negative 2 over radical 2, and then I'm going to do the same thing, and my answer is just going to be negative radical 2. And then cotangent is the reciprocal of tan. So if tan is negative 1 over 1, I take the reciprocal of that is still negative 1. Alright, so for each one of these problems that you have to do for your practice 1 and practice 2 this week is just use the unit circle, find the x and y coordinate, and then use that to help you evaluate each trig function depending on which one they ask. Let's do one more. If you feel like you're good, then you can pause and you can try the problems. But the next problem is also from your worksheet, from your first practice assignment, number 9. We're going to do the same thing, but now we want 13 pi over 3. Okay, so 13 thirds of pi, that's the angle. Let's look on your unit circle and see where it is. So I'm just going to get rid of all these first. And the angle that I want is 13 pi over 3. Oops. 13 pi over 3, so 13 thirds of pi. And so let's take a look at where that would end up being. So this is 1 pi, okay? And if I take it by thirds, this would be 1/3, 2/3, this is 1/3, and then this is 2/3, right? 1/3, 2/3, 3/3 would be 1 whole pi. So if 3/3 is 1 whole pi, that would be a half circle. Then 6/3 would give me 1 full circle, right? 6/3 would give me 1 full circle. That means 12/3 would give me another full circle. And then after 12/3, I have still a third left to get to 13/3. So I'm basically breaking this up as 6/3, which is 1 full circle, that's 2 pi, plus another 6/3, that's another circle, so I come back around to the same spot. That's going to give me 12/3, and then I still have 1/3 left, okay? And that would put me right here, which is the same spot as pi over 3. And these are my coordinates, x comma y, which corresponds with cosine and sine. Okay, so I'm going to say that this is the same as pi over 3, because I just come back around to pi over 3, and my x and y coordinates are at pi over 3. Let's get your unit circle. X is 1/2, and y is radical 3 over 2. Both positive because I'm in quadrant 1. So just be careful with the positive and negatives depending on which quadrant your angle lands in. So remember we had said x is cosine and y is sine. So using that, we're going to just fill it in. Sine is going to be radical 3 over 2. cosine is 1/2, tangent, so sine is y, cosine is x, tangent is y over x, right? So tangent is going to be radical 3 over 2 divided by 1/2. And when I divide fractions, remember we keep, change, flip. So I'm going to do it down here. Keep the first fraction, change division to multiplication, and flip the second fraction, and then multiply across. And so that's 2 radical 3 over 2. The 2's cancel out, and I just have radical 3. Okay, and then cosecant is the reciprocal of sine. So instead of radical 3 over 2, we now have 2 over radical 3. Again, need to rationalize the denominator. No radicals in the denominator. So I'm going to multiply by radical 3 over 3. That's going to give me 2 radical 3 over 3. And I can't simplify that any further. Secant is the reciprocal of cosine. Reciprocal of 1/2 is just 2 over 1, so that's nice and easy. And then cotangent is the reciprocal of tan. So if tan is the square root of 3, then cotan is just 1 over the square root of 3, which again we have to rationalize the denominator. So simplifying that gives me radical 3 over 3 in the denominator. And that's it. So your final answers for sine, cosine, tan, cosecant, secant, and cotangent. First step for every problem is find the angle on your unit circle and then identify the coordinate of the point on the terminal side of that angle, x comma y. X is going to give you the cosine and y is going to give you the sine. And if the problem only asks for cosine and sine, you can just write it right in because it's given to you in the point. Okay. If the problem asks you for tan, cosecant, secant, or cotangent, then you have to do a little bit of work and evaluate it like that. That's it. That's it for this week, guys. Thanks.